Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at our study guide. And I do want to stress to you that if you're watching this immediately at the beginning of the blocks, you are ready to take the test and you want to just make sure you got all your answers correct. I am on the Google Meet and I am going over this in real time. Of course, this is assuming you're not watching this many, many days after the fact and reviewing things, then just ignore everything I'm saying right now. But if you are doing this in real time and it's Friday morning on January 29th of 2021, and you've got a question about something, feel free to come back onto the Meet, ask me questions. There's nothing wrong with doing that. And any question that you ask me, I'm sure everybody else that's on the Meet and everybody in the classroom will appreciate hearing that question and hearing my answer. Once again, if you are in the future at some point and you can't travel back in time to January 29th, 2021 to jump on the Meet, then just do the best that you can or send me an email and I will clarify anything for you. Okay, so first of all, this test is on the 5D process. And the 5D process is just CPM's method for getting you to read through the problem, pull out the essential information, figure out the relationship between the numbers and the parts that you know and the parts that you don't know, and then coming up with some kind of a plan to figure out how you're going to solve the problem. We started off with creating tables and doing a guess and check process. Then we started to move toward writing equations that represent the situation and then solving the equation, and then we've got our answer. And so once you come up with a process, then go through and implement the process. That's the do. So describe, define, do, and then you want to check your answer to make sure that it's correct. So you're going to decide if you got everything correct. When you're doing the guess and check, you're going to probably have to decide multiple times until you finally get to the right answer. When you're solving an equation, then you want to just check to make sure that the answers that you got match up with the definitions that you think are correct for the situation. And once you have decided my answer makes sense, I'm pretty sure, I'm 100% sure I got the correct answer, then you declare your answer properly. And if it's a money problem, you put in dollar signs. If it is a percent problem, you put a percent sign. If it is a word problem, you use the appropriate words. And if it's a measurement problem, you put in the appropriate units of measurement. Okay, so 5Ds, don't think that this is a new problem-solving process. It's not. It's just problem solving. It's just the way that people who are successful with word problems go about solving those problems. So here's an example of using the guess and check table. Excuse me, I have to spit out some gum. I may edit that out, or maybe I won't. I don't know. Okay, so a wood board 100 centimeters long is cut into two pieces. All right, so that's good to know. It's cut into two pieces. One piece is 26 centimeters longer than the other piece. So it sounds like we've got two different pieces. And so we're going to define the first piece will be X, and the second one is 26 longer. So that would be X plus 26. So when we're doing our guess and check process, we want to make up a number for the first piece. Then for the second piece, we'll add 26 to that number. And when we add those two numbers together, it's supposed to equal 100 centimeters. This number right here. So that's let's see what we've got here. I technically didn't show you the describe portion, but this is define, this is the do, this is the decide, and this is the declare. So we went through the process. 20 was too low, so then I plugged in 30. Turns out 30 was too low, so I plugged in 40. That's too high. Why didn't I write high there? I should have written that for both of them. I'll go ahead and do that right now. This is also too high, and this was also too low. Okay, whether or not you write those in there really doesn't make that much difference, just so that you make a mental note of whether it's too high or too low. So then from 40, since 40 was the first one that was too high, I'm going to back it up a little bit. Now, a little bit of strategy here. 86 is 14 away from our target number. 106 is only 6 away from our target number. So if I were going to choose for my next number, I would want to choose something that was closer to 40 than 30, since 106 is closer to our target than 86 was. So that's why I went to 38. But it's still, 38 was too high, so I went to 37. And so after 1, 2, 3, 4, 5 guesses, 37 plus 26 is 63. And when you add 37 and 63 together, you get 100. So that means we've got our answers. The two pieces must be 37 centimeters for the first one and 63 centimeters for the other one. Now, I'm going to encourage you to try and solve these algebraically. So let's take a look at this problem and see how long it takes me to solve it algebraically. I've got two pieces, right? I got the first piece, which is defined by x. I got the second piece, which is defined by x plus 26. When you combine those two pieces, the answer is 100. So we're going to solve this equation by using legal algebraic moves. First, we combine like terms. The x and the x make 2x's, so let's simplify that expression. Then 2x plus 26 is 100. Well, I want to know what the 2x's were before I added the 26 in. So let's take that 26 back out, and 100 minus 26 is 74. These guys cancel out, and so you know that the 2x's before you added the 26 must have been 74, since 74 plus 26 is 100. Now, 2 times something is 74. What are you going to multiply times 2 to give you 74 for an answer? This is where we go back to our 3rd and 4th grade fact families come into play. If 2 times x is 74, then 74 divided by 2 will tell you what x is. So let's take and divide both sides by 2, so you get a giant 1 there. That's 1x is equal to whatever this answer is, which is 37. Now, I don't want to just declare that as my answer, because I need to make sure I didn't make any mistakes. So according to our definitions, the first, if it's 37, the second side has to be 26 more than that. So I will add 26 to 37 and get 63. And when you add 37 and 63 together, do you get 100? Yes, we do. So taking this time to check, that's your decide. We know we've got our answer correct, so we will declare our two pieces are 37 and 63. Okay, so which one took longer? The table or the algebra? Generally, the algebra is quicker, and it's more efficient, and it eventually gets easier, especially if the two pieces were decimal numbers. If this was 37.14 and this was 62.86, you'd be guessing and checking for a long time, and you would be miserable. Solving it algebraically and using your calculator, 1, 2, 3 steps to get to your answer. And the first step was just combining like terms. So this is always going to be more efficient. So this is the direction we want to move in. Oh, I didn't want to do that. There we go. All right, so I've got a little board here. I'm not going to solve every one of these. I'm just going to do a couple of them. And if you have any questions about the ones that I don't do, then send me an email, and I will work those out for you. Or if you're doing this in real time, jump onto the Meet and ask me a question. Okay, so 2 is 5 years older than her brother, Twan. So we know we've got 2. Wait, how do you spell that? 2 and Twan. It says 2 is 5 years older than Twan. So if Twan is 10, 2 is 15. So we'll make him x, and we'll make him x plus 5. So 10 and 15, yes, that absolutely works for our definitions. Then it says the sum of their ages is going to be 51. So I have combined our describe and our define sections right here. So what should we do? Should we do guess and check? Or should we solve it algebraically? Let's check. Hold on for a second. I'll be right back. All righty, got that squared away. All right, so now we're here. Once we've got our equation, x plus 5, right? 2's age plus Twan's age is equal to 51. Now let's solve. Let's go ahead and combine like terms. That becomes 2x plus 5 equals 51. So what was the 2x's, excuse me, before we added the 5 in? Let's take the 5 back out. And we see that 2x's was equal to 46. Why did I write this over there? That should be slid over a little bit. Okay, we'll just leave it like that. 51 minus 5 is 46. Yes, it is. So now we divide each side by 2, and you get x is equal to 23. So if Tuan is 23, that was the x, right? Tuan, and 2 is 5 years older, then 2 would have to be 28. And let's check it. Is 23 plus 28 equal to 51? Yes, it is. We feel good about our answer. We declare our answer and put a box around it. So that is the process that we are going to use for most of these problems. Looking at problem number 3 with Thomas. He says he's thinking of a number. So in this case, we're just going to make x equal to that number. We don't have multiple variables here. We just have the one number. So it says he triples the number, then subtracts 13. His result is 305. So we just solved it algebraically. Let's add 13 to each side to find out what the 3x's are equal to. And they must be equal to 318. See how it says 3x equals 318 there? Because we canceled out the negative 13 when we added its opposite to it. Formed a zero pair. That becomes 3x plus 0, so we'll just call it 3x. But whatever you do to the left side, you have to do the same thing to the right side. So now what do you multiply times x to give you 318? We'll take 318 divided by 3, and that's going to give you 106. So that means the number that he was working with must have been 106. So let's go ahead and check that to make sure. What is 106 times 3? It is 318. So you triple the number, then subtract 13 from that. Do we get 305? Yes, we do. We feel good. Declare that answer. All right, where are some other ones here that might be, oh, you know what I should do? Let me do the one that has to do with consecutive even numbers, because there is a problem that has to do with this. I think the test problem has 3 consecutive even numbers instead of 2 consecutive even numbers. But the idea is the same. You got the first number, which we're going to call x. You got the second number, which has to be 2 more than that, right? Because if you're talking about even numbers, it could be like 2, 4, and 6. This one is always 2 more than that one. This one is always 4 more than that one. In this case, we're only talking about 2 numbers. So this is going to be x plus 2, right? So if x is equal to 2, then the second one has to be 4, because 2 plus 2 is 4. If x is equal to 10, then the next one has to be 12, because 12 is 2 more than 10. So now what do they say about the sum of these 2 consecutive numbers? It is equal to 246. So we're going to take 2 x's plus 2, right? X plus 2 is 2x plus 2 is equal to 246. So now we begin the process of solving. So the 2 x's must have been 244, because 244 plus 2 is 246. And then what do you multiply times 2 to give you 244? Well, we can do that, right? What's half of 244? That is 122. That means the first number had to be 122, and the second one must be 124, right? Because that's the next even number after 122. And when you add those 2 numbers together, you get 246. So we know we've got the correct answer. Okay, so just remember, when you're taking the test, when you have 3 consecutive numbers, the third one is going to be 4 more than the original one. So you have 3x's plus 6 is going to be equal to whatever the sum of those 3 numbers is. How much time are we at? We got a little bit more time. This problem 7 and 9 are actually a lot more complicated. I circled them for a reason. They're a lot more complicated than anything you're going to see on the test. So I'm going to say, if you didn't understand how to do those, next year when we learn about systems of equations, it'll be easier for us to solve those problems. Let's not worry too much about those now. If you're using the guess and check table, you could get the answers. And so you'll see, what the answers here are on the side. Let me just move this guy out of the way and scroll down. Is there another good one in here? Number 10 is another one that's really tricky. Number 12 is one that involves nickels, dimes, and quarters. This is one where it gets tricky because not only do you have to factor in the number of each one, but you also have to consider the value. So in this problem, if we, what does it say? Conrad has collected 3 types of coins, nickels, dimes, and quarters. Nickels are worth 5 cents, dimes are worth 10 cents, quarters are worth 25 cents. It says there's an equal amount of nickels and quarters. So these two will be the same. Those are both X. And there's 3 times as many dimes as there are nickels and quarters. So that would be 3X. So whatever number I plug in here, I'm going to keep the quarters the same, but I'm going to multiply it times 3 to get the number of dimes. We're not focusing on the number of coins here. We're focusing on the value of the coins. So this is where, to make it a little bit easier, I changed it from $9.60 to 960 cents so that we could just think about these as 5 cents, 25 cents, and 10 cents and not worry about focusing on the decimal numbers. So if you have 20 nickels, that's $1, but we'll call it 100 cents. If you've got 20 quarters, that's $5, but we'll call that 500 cents. And 60 dimes, that would be $6, but we'll call that 600 cents. So what does that all add up to? It adds up to $12, which is 1,200 cents, and that's too high. So let's lower it. Go down to 15 and 15, this becomes 45, and then 15 nickels is 75 cents. 15 quarters is $3.75, and 45 dimes is $4.50. So when you add those together, you get a total of $9 or 900 cents. So that's too low. So let's now guess 16, 16, and 48. And that is the winning combination. 16 nickels is 80 cents. 16 quarters is $4. And 48, remember 3 times these numbers is 48. 48 times is $4.80 or 480 cents. Add those all together, you get $9.60, which is 960 cents. And then once we know that that is correct, then we're going to declare the number of nickels, the number of dimes. Oh, that's the number of quarters, isn't it? And the number of dimes. And then you've got your final answer. Okay? Okay. So if you've been practicing all along, you should do okay on this test. Remember, you've got the option of either setting up the guess and check table or setting up an equation and solving the equation. Take your time on it. You will do fine. It's a multiple choice test on the Google form. If you're in class and you're in the future, well, it's not multiple choice. You have to work things out and declare your answer like we did here. But still, if you go through the 5-day process and you check your answers and you make sure you don't declare an answer until you're 100% certain you got it correct, you should be fine. Okay? Okay, let's move on to our next activity, which I believe should be a chapter test. Take care. Bye.
Hey, feeling good, like I should. When in dark, I walk around the neighborhood. Feeling blessed,